Hey Emilia, what's up?
I'm bored.
Wanna do something fun?
Like what?
Let's do an experiment about vectors and equilibrium.
Okay. Experiment about.
Well, in this experiment, we are going to learn about vectors and how to use the analytic and graphic method. And also, we're going to learn how to get the final vector using a force table.
Let's go! Wait, but what's a vector?
Well,
a vector is a quantity such as velocity completely specified by a magnitude and a direction. It consists as the action of forces acting over an object. A scalar is the measurement of a medium strictly in magnitude. Vectors are different from scalars because they have a direction that indicates the angle. For example, if I say a person walks 25 meters, that's a scalar, but if I say a person walks 25 meters to the right, that's a vector. Just like scalars, vectors can also be positive or negative. A negative vector is a vector which points in the direction opposite to the reference positive direction. Vectors quantity may be applied while traveling, moving, doing sports, etc. They are related to physics. Vectors are important for our daily lives.
Wait, I have a hypothesis. The result of the graphic method, the analytic method, and the force table are gonna be the same?
well, we're going to find it out.
First, we need to assemble the force table. Then put the ring in the middle. Put the first pulley at 80 degrees. Then the other pulley at 180 degrees. And the last pulley at 220 degrees. Add 43 grams to the first pulley. Then add 23 grams to the second pulley. For the last pulley, add 63 grams. Do the analytic method to get the summatory of x. Now do the same process to find the summatory of y. With both summatories, do the final vector formula to get the result. To get the angle, we'll use tangent and divide the summatory of j over the summatory of x. To find out the quadrant, we'll see both summatories. The summatory of j is positive and the summatory of x is negative. Therefore, it will be in the second quadrant. For example, we have vector a and vector b. The final vector will be in the middle, and the balancing vector will be the contrary of the final vector. Therefore, it will be in the third quadrant. Because our final vector was in the second quadrant, our balancing vector will be in the fourth quadrant. Therefore, we will subtract the angle to 360. We will put the last pulley at 358 degrees and then put a weight of 63 grams.
We finished!
Let's see the results.
The analytical method can be described as a combination of steps that utilize the Pythagorean theorem as well as the trigonometric identities. These two concepts determine the magnitude and direction of the resultant vector. The graphical methods find the resultant vector by using Cartesian geometry. In our lab, we draw a line of 4.3 centimeters at an angle of 80 degrees, then another line of 2.3 centimeters at 180 degrees. The last line was of 6.3 centimeters at 220 degrees. Then we connect the starting point with the final point and we get 6.3 centimeters. A force table is a tool for demonstrating Newton's first law and the vector forces. This tool is based on the principles of equilibrium. By using simple weights, pulleys, and stripes placed around a circular table, several forces can be applied to an object located in the center of the table in such a way that the forces exactly cancel each other, leaving the object in equilibrium. At the end, we can agree that the analytical method is the most exact, then the graphical method, and at the end, the force table.
In this lab, I learned a lot about vectors. What types of problems did it use to calculate the direction and the magnitude? Also, I learned the analytic method, how we use to solve a problem correctly, and the table force to calculate the degrees and the weight. We have to place the pulley to place the ring.
But the most important part is that the hypothesis was true. For this problem, we just did a symmetry between the two quantities they gave us and got 38 newtons. And with the minimum, we just subtract 13 newtons to 25 and got 12 newtons. As in the problem said, one block equals 100 meters, we use that meter and change it to 1 centimeter. And with those units, we draw the units, as in 8 blocks to the west, 2 blocks to the south, and 15 blocks to the northeast. So when we got the final point, we connect them with a ruler marking how much they measured, and with a protractor we measured the angle and got the result, which was 80.9 blocks, 73 degrees. And just to prove if we were right, we did the analytic method and got the same answer. In problem number 3, we just find out the angles and did the analytic method.